Today in this video, we're going to be covering arithmetic sequences or arithmetic sequences, whichever way you want to pronounce it. So what even is arithmetic or arithmetic? I'm going to say arithmetic. What even is an arithmetic sequence? Well, you've dealt with it your entire life. You know, listing the odd, the even numbers, 2, 4, 6, 8, 10, on and on. That is a arithmetic sequence. The list of even numbers, or the list of odd numbers, 1, 3, 5, 7, 9, and ... It goes on and on and on. A sequence is a set of numbers in some order, and we call each number in that sequence a term. So this is a term, this is a term, this is a term. We call this the first term. 1 is the first term, 3 is the second term, 5 is the third term. So 1, we can call this term 1, T1. This, T2. This, T3. 3 is T2, 5 is T3 because 5 is the third term. So we can just say Tn is the general term, the nth term. Now take a look at this sequence, 8, 13, 18. Right away you can see, okay, it's going up by 5s. However, look at a ... here. When you see these 3 dots, you know that this goes on forever. So this is an infinite sequence. There's no end number of terms. However, this, we know the last term. It's 63. So even though there's a lot of terms in between, we know the last term. So this is a finite sequence. We know the last term. We can determine the number of terms in the sequence. In mathematics, this is the Fibonacci sequence. So basically, each term that follows is a sum of the previous 2 terms. 1 plus 0 is 1, 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 2 is 5, 5 plus 3 is 8. Take a look at the sequence, and I want you to tell me what will the next 3 terms be. You have 5 seconds. 5, 4, 3, 2, 1. If you said 16, 19, and 22, you are correct because it is going up by 3s. 13 plus 3 is 16, plus 3 is 19, 19 plus 3 is 22. And what else we know is that the value of each term can be determined by knowing what the constant difference is. So between 4, 7, 10, 13, 16, 19, 22, it's a constant difference of plus 3. This is what we refer to as the common difference. And this common difference can be negative or positive. And to determine this common difference, you want to do 7 minus 4. You want to do the second term, subtract the first term. So T2 minus T1. Or alternatively, you could do T3 minus T2, which would be a 10 minus 7. Or you could even do T4 minus T3, which is 13 minus 10. What you don't want to do is do T1 minus T2 because this will give you a negative value. 4 minus 7 is negative 3. And that's not your common difference in this sequence. That's a false statement. Take a look at this sequence. Right away, we see that the common difference is 4. It increases by 4. Let's label our common difference as D and say it is equal to 4. Now what is T1 here? T1 here, the first term, is 4. T2 is 8. What we can also say for T2 is that T2 is equal to 4 plus the common difference, because the common difference is 4, and T2 is 4 plus 4. Alright? So 4 plus D. But what is 4? 4 is also T1, so we can say that T2 is equal to T1 plus D. What about T3? T3 is equal to 12. But we also know that T3 will be equal to 8 plus D. And as we can see, 8 is T2. So we can say that T3 is equal to T2 plus D. But what we also know is that T2 is T1 plus D. So T3, you substitute T1 plus D in to T2, it'll be T1 plus D, and then take the plus D from here, plus D. You combine like terms, and then once you combine like terms, D plus D, you'll get that T3 is equal to T1 plus 2D. And this pattern continues. Take a look at T4. T4, we look at the sequence, it's 16. T4 is equal to 16. 16 can just be 12 plus D. And what is 12? T3. So T4 is equal to T3 plus D. And then you can substitute what this is, and we'll get that T4 is equal to T1 plus 2D plus D from this. And then you combine like terms, you'll see that T4 is equal to T1 plus 3D. So we got a formula from this. The general term, Tn, is equal to T1 plus n minus 1 common difference, which is D. T1 is the first term, Tn is the general term. So for example, if you're trying to find the 50th term in a sequence, you replace n here with 50, so it'd be T50. Okay, so find the formula for the nth term of this arithmetic sequence on the screen. Okay, so term 1 is 2, so Tn is equal to 2 plus n minus 1, and the common difference, 5 minus 2, is 3. Okay, so here's our formula. Now let's find the 15th term. 15th term, okay, so n is now 15. T15 is equal to 2 plus 15 minus 1, 3. Okay, T15 is equal to 2 plus 14 multiplied by 3. T15 is equal to 2 plus 42. T15 is equal to 44. So the 15th term of this sequence is 44. Okay, so term 1 is 107 plus n minus 1. And the common difference here is actually going to be negative. Let's do 98 minus 107. We're going to get minus 9. But when we find out 100 term, should be pretty low. 107 plus 100 minus 1. 84. This is the 100th term of this sequence. So from that question right now, we know that negative 784 is equal to T100. So which term has the value 220? So let's get our formula again. It is asking us to solve for n, because n is the number of terms. It's asking for which number term has the value 220. So is it the 30th term, the 50th term, etc., etc.? So here's what we know. 220. This isn't T1 because we know T1 is 3, and the common difference here is 7. And we don't know what n is, but what we do know is Tn is equal to 220. Because as we know from earlier, T100 was equal to negative 784. So if we know the value of Tn, we can try and find n, if that's easy to understand. So 220 is equal to term 1, 3, plus n minus 1, and 7. So I'm just going to do minus 3, 217 is equal to n minus 1, 7, divide by 7, divide by 7. 31 is equal to n minus 1, plus 1, plus 1, and you'll get that 32 is equal to n. So now we know that the value 220 is the 32nd term of this sequence. Meet Greg. He's not insane. Look at his smile. And what he likes to do at any time of the day, whether it's 2 p.m. or 4 a.m., he likes to cut apple slices. And here are the lengths of the first 3. So, let's develop a general term for the sequence. T1 is equal to 15. And as we can see, the common difference, 21 minus 15 is 6. So, Tn is equal to T1 which is 15, plus n minus 1, and 6. Now for the next question, what will the length be of the 4th apple slice, the 5th apple slice? Okay, get t1 in there, plus n, 4 minus 1, common difference 6, 33 centimeters. These are some big apple slices. The 5th one will be 15 plus 5 minus 1, 6, which is 39 centimeters. Now, if we were to graph this, having n be on the x-axis and the value of that term be on the y-axis, we're going to get a linear line. And what you'll notice is the slope of this line will be your common difference. So y2 minus y1 over x2 minus x1. And the slope of this line is 6. Here's something that you must know. When you graph an arithmetic sequence, it's going to be a discrete graph. You're not going to connect the dots. You're just going to leave it as is. Because the sequence is only defined at the whole number of values of n. It's not defined at n equals 1.5 or n equals 2.5. Those values are meaningless. When you connect it with a line, you're inferring that there are meaningful values in between n equals 1, n equals 2, n equals 3. And that's just not the case. So you just leave it like this, just the dots. You are given term 4 and term 8. Let's label this term 4, term 5, term 6, term 7, and finally term 8. So if you add one common difference, you get to term 5. If you add another common difference, you get to term 6. And if you add another common difference, you get to term 7. If you add another common difference, you get to 53. So 5 plus 4 common differences is equal to 53. Okay, this is so easy. Minus 5, minus 5. Divide both sides. D is going to be equal to 12. Okay, now we have solved this. Now what is term 1 going to be? 1 common difference, 2 common difference, 3 common difference. So we can notice that the sequence, look at term 4, term 8, is increasing. So if we go backwards, it's going to be decreasing. So instead of doing 5 plus 3d, we're going to do 5 minus 3d to get term 1. So we know that term 4 minus 3 differences is equal to term 1. Term 4 is 5 minus 3 differences, which is 12, is equal to term 1, which means that negative 31 is equal to term 1. So from the previous question, let's do the third problem. So term 18 is equal to the first term, negative 31, plus n, which is 18, minus 1, and the common difference, which is 12, 173. So now I want you to tell me how much terms are in this entire sequence. Because there's a dot, dot, dot. So there's a bunch of terms in between 136 and 21. Because it ends with a 21, remember from earlier in the video, this is a finite sequence. And because the sequence ends at 21, we can determine that 21 will be the final term of the sequence. So if we figure out what term 21 is, then we know how much terms there are in the sequence, because 21 is where the sequence ends. 21 is equal to 141 plus n minus 1, and the common difference, negative 5. So let's do 21 minus 141. You'll get negative 120 is equal to n minus 1 minus 5. Divide both sides by negative 5. You'll get that 24 is equal to n minus 1 plus 1. 25 is equal to n. So 21 is the 25th term of this sequence. And 21 is also the final term of this sequence. Which means that there's logically nothing beyond 21 in this sequence. So that means that there are 25 terms in this sequence. So for this problem, we have to find out what the value of x is, such that these three terms form an arithmetic sequence. Okay, well, how do we solve for x? We don't even know what we're supposed to equal to each other. To solve for x, you have to have an equation. We know that the common difference is equal to t2 minus t1. We also know that the common difference is equal to t3 minus t2. So let's do this first. So term 2, 3x minus 1. 3x minus 1. Subtract term 1, x plus 2. X plus 2. Once you combine the terms, you're going to get that it is going to be 2x minus 3, which is equal to d. Now let's do this one. Term 3 minus term 2. Term 3 is this one. 2x plus 1. Subtract 3x minus 1. 2x plus 1 minus 3x plus 1. You combine the terms, you're going to get minus x plus 2. So if this equals d and this equals d, then these are equal to each other. So we can equate them to each other. Plus x minus 2 minus 2. You get 3x minus 5 is equal to 0. Once you solve for x, you get that x is equal to 5 over 3.